Hi, today I'm going talking about this one, the cons symmetric integers. This question is not popular. You can see recently no company asked this question. It's not popular under this question a little bit tricky. So let me go through this question. So you are given two positive integer low and high. An integer x consisting of two times n digits is symmetric if the sum of the first n digits of x equal to the sum of the last n digits of x. The number with the odd number of digits are never symmetric, so it should be even number of digits are symmetric. So return the number of symmetric integer in the range low and high. So you can see it's including low and high. So here, you can see this is our input, and here is output. The output is 1, 1, 2, 2, 3, 3, 44, 55, right? So it should be even, and the first digit equal to last digit, sum of last digit. Okay, the first equal to 1, right? First digit is 1, the second half digit is 1, so they are equal. So now let's see this second example. It starts from 1200. The high is 1230. So you can see here start from 1200. So only for number, right? Only a four number are symmetric. So you can see first two number we sum up the first two digits equal to 3, the last two digits equal to 3, so they are symmetric. And the question a little bit confused. And here also 3 equal to 3, right? And 3 equal to 3. Here also 3 equal to 3. So then next one return 4. So here you can see the constraint. It starts from 1 and time power 2, right? So now we can, for example, we have this range. This range, so it's 1, it's 9, and 10, and then 99. So we need to break the because here's the 10 power 2, right? We can break the entire to the 4 part into 4 part. So I can show you how to think about this one. And here should be you can see 99, 100, and here should be 100 now. So here can be 99, right? Because 4 digit, it should be maximum. So we know here it's just 1 digit, right? It cannot be, we cannot get any symmetric number. So we just count this out. We don't need to think about it. And here 100 from 100 to 999 is also is 3 digit, right? So we also doesn't need to think about it. So if first step we need to check if low and high in this range. Okay, we just return 0 because we cannot find any symmetric number. And here also low and range, low and high in this range, we just directly return 0. And here now we know these two parts we need to directly return name. So here we just only think about how many symmetric in these two parts. So the test case can be can be like this one. Its first test case is from 10 to 99, just in this range. Maybe second test case can be here, and the third test case can be here, right? There have three possibility. We have these three test case. So here we will create two functions. One function is used to calculate and or I would say used to count the number of symmetry in this range. And the second function is used to calculate the count the number of symmetry in this range. So we have two function, and then now we have three test case, right? The test case can be maybe low high in this part, or low in from 10 to 99, and the high in from 100 to 999, or is close to the in the 4 digits here, right? So in this, so we know the low is, for example, maybe low is 45, and here maybe is 98. If the test case in this part, we just keep it, and we can find the symmetry in this range. The second maybe second test case from here to the 88, because we know from 100 to 88 we cannot find any symmetry. So here, so we need to update our high, so we can cross this out and update the high to the 100. So we use this way can save a lot of time, right? We don't need to waste our time to go through 100 to 88, right? So, and the second test case maybe is the third test case maybe from 45 to maybe 222, okay, 222. So we know 45 will cross this 199, right? So here we can do one thing. We can break this range into two parts, and here start from 1000. So we don't need to calculate this from 100 to 999, right? Because within our time, we can just skip it. Then we can divide this low and high into this part. And how to get this high? So we need to check the low is smaller than the low is smaller than 100. If yes, we just use the max. We just keep it. If we know 45 is less than 100. Okay. Now how to get the 6A over 100? Because we need to update this. So we have mathematics, right? Provide the method like minimum. We use the minimum. If the current high and 100, so we need to check which one is smaller. If the test case first one, we know the high is still 68, right? 68 is less than 100, so still keep it. We to keep it, so we can use this range to find the symmetry. And the second, now we can see in the second example, it's 88, right? So now 88, the high is 88. Now we're just comparing 888 with the 100. So we know 100 is smaller. So we just update high to 100. So we assign 100 to the high. So here should be 45 from 45 to 100 because we don't need to wasting our time, right, to do this one. We just only find a symmetric number in this range. And then third example. Here doing the same thing. Now we know the height is the 2222. So we still outdated. So we got 100. So we just do this. We calculate this one, but here we still have no 1,000 from 1,000 to 2,222, right? So here, so that's why I mentioned we have two functions. So the second condition we need to say if the height is greater than 1,000, okay, which means we need to update. We need to update with our row, comparing. If we know the row is 45, we use the maximum now here. Comparing 45 with 1,000. So which one is bigger? Okay, we just update it. Okay, 1,000 is bigger, so we just cross this out. So here you can see we execute these two range. We perform these two range, right? So that's my logic to solving this question. Now I will show in the coding. This question, so you can see here the two test case. So if the height less than equal to 10, we just directly return 0. So we cannot find if the height less than 10, which means the low also less than 10, right? So it should be return 0. And the second condition, if the low greater than equal to 100 and the high less than equal to 1,000. So in the third range, we just directly return 0. Now here, just I mentioned if low less than 100, so we need to update. You can put 100 because we know 100 is the all digit, right? 3-digit layer, so we cannot find. So that's why I just decrease by 1. Or you can use 100 here. It doesn't matter. Now, here, we will call it function. So here we know, we just check the first one. If for this example, we start from 10. 10 minus 10, no. Just I in the beginning already get maybe 44, right? Maybe 44 here. Type 10, we got a 4, right? 4. If we start from 4, and 4 times to 10 plus the 10, because you can see in this range, the two numbers should be symmetric, right? 1, 1, 2, 2, 3, 3. So you can divide by 10 because only 2 digits in this range. So you can get the first half times to 10 plus the first half. If the noun this number in this range is still less than the high and greater than equal to low, so we can say we find the symmetric. So we need to increase by 1, and we actually we don't need to 45 or 46 or 47 to increase this. We just increase the 4 and the 5 first digit, because we know only in the first digit we know only 44 is symmetric, 45 is symmetric. So even though you 44, 45, 46, so you don't need to do this one, right? It's waiting our time. We can quickly use this way to find the symmetry, number of symmetry in this range. So it will can improve the time capacity. And then now here just I mentioned here. So we need to check the height if greater than equal to 1000. Okay, we need to find the maximum. Use the current row with the 1000. Which one is maximum? I already gave the example here is 45, so we don't need to, because 45 will come across the 100 to 999. We don't need to calculate this range, this part, right? So we just directly cross this, scale this the range, and then to find the low. In this way we can save much time, and then here you need to find. Now we call this one here. So we know we can divide this 4 digit into two part, right? First 2 digit and the last 2 digit, and then so we got the first half and the second half, right? And then we divide by 10, which means we got the first digit. First half by 10, we got the second digit, right? Of the first half. And here it doing the same thing, right? In the third digit, fourth digit, you get second half divided by 10. The second half multiplied by 10, right? So now we just add first digit plus second digit. Whether first digit plus second digit equal to the third digit plus fourth digit. If yes, we just count, just increase by one. And then we need to increase by one to find all the number of symmetry in this range, and then we return count. Now let's see. Let me run it. So you can see it's a bit 92.29%. So the time complexity is, I would say, because I skimmed 2 pi, it should be a big of n. Yeah, it is in the worst case, it should be b of n. The time space complexity is constant time because I didn't use extra memory. I didn't use the hash set or hash map or the create new array. I didn't use any memory here, so it should be constant time. So thank you to watching this video.